Okay, so let's move on to the 19.29. So, okay, so here's the diagram. Let's draw a big picture. So we have a circle O, and the two chords with the midpoint of M and N. Yeah, so we know from the O to the midpoint, right? This is the perpendicular, okay, to the chord. Then intersect at P. So we want to prove the MN is less or equal than OP. Okay, so first, very simple, we need to see, because this angle plus this angle is 180, so that's why the MONP is concyclic, right? So if MNOP is concyclic, right? So, and this one is 90 degrees, so you know OP is diameter, right? So that's why, I mean, for any, if there is a circle here, right? The diameter is the longest, okay, which is longest chord in a circle. Okay, so that's why. Okay, this is the first answer. The second question is, when could they be equal, right? So if OP equal MN, that means they both are diameter, right? Okay, so think about it, okay? If we have a circle and both of them are diameter, okay, here's OP, here's MN, both of them are diameter. This is the center C, right? So this diameter will construct a, so we have the 90 degree here, 90 degree here. Here's another diameter, 90 degree here, 90 degree here. We'll construct a rectangle. So that means when the MPNO is rectangle, okay, so they are equal. Next. So the RS, we have a triangle ABC. Okay, and the RS are the segment of here and the segment of here. BC and AC. Then we have the AR and the BS intersect at P. Okay, so if what is the area of the ABC? So the goal is, what is the ABC? If you know the APS is 5, the APB is 6, and the BPR is 7. Okay, so we know the 5, 6, 7, right? The goal is, if we can figure out this one, that's it, right? So see, because the APB, right, and the APS have the same height, right? Right? So you know this one is the 6, this one is 5, so we know this is a 5t and a 6t, and this is a 5t, right? So the same reason we know AP and RP, right, is 6 and 7, so we know is 6p and 7p, right? Okay, now we try to solve this area, right? So we still need to cut in the ratio, see? Because we know the ratio, we know the ratio of this one and this one, right? And we know the ratio of this one and this one, right? So we need to fully utilize it. Okay, so the first is we can see, let's see, this is the B and this is the A. Okay, so we can see the 5 plus A, right? So we know the AP over RP is 6 over 7, right? Means 5 plus A, the area of 5 plus A over B is equal to 6 over 7, right? The second one is this one, right? We know BP over PS, right? So that's why you know the 7 plus B over A, right? 7 plus B over A is 6 over 5. Okay, now we have two equations, 1 and 2. By solving the equation, okay, we know the A equals 385 and B equal 455. So the total area SABC is equal to 385 and 455, then plus the 18, right? 6 plus 5 plus 7, that's 18. So the final is 858. Okay, so this one. Next is so if you read the problem said if we have a chord of AC and we have a perpendicular bisector, so the perpendicular bisector of AC is this line M. It must passing through the circle center of O, right? Also here is the point of P, and then the CP, this arc, right, is equal to this arc. Okay, so this is the B. Okay, this is the midpoint, and we know the arc is theta, right? So means the AOB, okay, is equal to the AB arc is equal to the theta. Okay, that means, and the AM equals BM means this is theta over 2 and this is theta over 2. Then this means this is the centroid angle, right? So this angle is half theta is a quarter of the theta, right? Okay, and think about M is the perpendicular bisector of AC, right? Means perpendicular bisector of AC. This means PA is equal to PC, right? So if PA equals PC, means this angle is also theta over 4, right? And the angle of this x, right, is the exterior angle of triangle APC, right? So x equal to APB is exterior angle of the APC, so it's a quarter of a quarter theta plus a quarter theta is half of the theta. Okay. Sphere Z is tangent to all the 6 edges of the regular tetrahedron. This is regular tetrahedron, ABCD, right? The sphere of the is tangent to the, so we have the side length of the 12 is tangent to all the edges, right? Now let's see. For the not regularly for all these things by symmetry, because you have the equal distance to all the edges or either all the faces, the first thing you need to do is to land the height from A to this one, okay? And this will be the center because the bottom is the equilateral triangle, so it's the center of the equilateral triangle, okay? Then you can have here is the midpoint, and this one, right? So now you can see what we want is we need to find a point, right? It has equal distance to here, and also has the equal distance to here, right? So this one is the T. This one has the distance to the CD, and has the equal distance to the AB. Okay. So now let's draw this picture here, okay? Let's equivalently make it in the same face. We already make it in the same face. Now let's draw it. So we have a A, B, Q, right? And this is center, this is the O, and we want to find a point to make these two sides equal, right? Let's see, this point is M, is T, and this is the P. Okay, so we want to find this one. And we know the side length is 12. So this one is the root 3 to root 3 of 12, right? Is equal to 6 root 3. That's this side. And this side is the same, right? And this one over this one is 2 to the 1. So 6 root 3 over 3. So it's 2 root 3. And the other is 4 root 3. Okay. Now we want to figure out a point. For example, we say this one is the x, and this one is the x. This one is the y, and this one is also the y, right? So we try to figure out what is y. Okay, so the first, by the Pythagorean theorem of the TOQ is right triangle. So we know that x squared plus the 12 is equal to the y squared. This is the equation 1, right? The second equation is from the triangle ATP, okay? Let me use a color. The second one is triangle ATP, okay? Second one is from the triangle ATP is similar to triangle ABO. Then that means the y over the 6 root 3 minus x is equal to the 4 root 3 over 12. Okay, so this is the BO over AB. Okay, so now you can try to solve this problem, right? From here, let's write here. From this one, we know the x equals 12 root 2 minus 3y over root 3. Okay, so you can apply the 3 into 1, then you will get a y function is y minus 2 of the y plus the 54 is 0. So you can try to solve y1 is 9 root 2 and y2 is 3 root 2, right? So, but we need to figure out which one is right, okay? So think about it. Y is within this triangle, right? And the y is the leg. So y should be less than AT. So we know y should be less than AT and should be less than the AO. Right? And the AO is 4 root 6. So y should be less than this, okay? So, but y1 is 9 2 greater than 4 root 6, so that's why this one's not possible. Then so the only y possible is y2 is 3 over 3 root 2, okay? So next, so the ABC is the equilateral triangle. With the side length of the 6. So prove that for any point P inside the sum of the distance to the 3 sides is DEF. So we want to prove that PD plus PE plus PF equals to constant, okay? So this is because for equilateral, we're always trying to use the 3 sides are equal, right? So you can see the ABC is equal to, for 3 of the side length square is 9 root 3. Then we can see it's also equal to the half of the 6 times the PD plus half of the 6 times the PE plus half of the 6 times PF. So you can see this one is equal to 3 PD plus PE plus PF is also equal to the ABC, right? Is equal to 9 root 3. So we can have the PD plus PE plus PF is equal to 3 root 3. So that's why it's a constant. This problem. So the UC and the point on the triangle M and H such that 620 S and 25. If they both have the equal area, so let's say this area is S, okay? And we have the angle. So per law of sine, S U N C is equal to S is half of the 6 times 20 sine, let's see, it's alpha, and S the M N H is equal to 2S is half of the 6 plus S and 20 plus S times sine alpha. So now we know the ratio, right? So you can see so it's 6 times 20 times sine alpha is equal to 6 plus S, then 20 plus S is half times sine alpha. Then we have equation of the S, right? So we find the equation of the S. So the S squared plus the 26S minus 120 equals 0. So S plus 30, then S minus 4 equals 0. So S equals 4. Next. So C1 and C2 are circles tangent externally, okay? So C1 and C2 touching point T. C1, C2, okay, so O1 and O2. Then P be a point on C1Q, be a point PQ is a common external tangent. That's this. So P and Q are external tangent. Let's connect it, always connected to the tangent point, okay? So we know this 90 degrees, and also we know this one, okay? Yeah, there is a construction, very important, okay? So we just do a tangent here. So then we make a M, right? Okay, if two circles are tangent here, and here is a common tangent line, okay? We must M is midpoint of PQ. So why this is the case? Let's prove it, okay? So you can see MT tangent to circle 1 and P tangent to circle 1, right? O1. So now you know from the power point, right? So you must have MP equals MT. The same reason you must have the MT equals MQ. So that's why you have MT equals MP equals MQ, right? So now you know this is the midpoint, right? Let's connect it with the triangle, okay? So this is the midpoint, and the median is also equal to this and this and this, right? So we must know this is the right triangle, okay? So from here, you can see the triangle PTQ is right triangle, okay? Okay, if PTQ is the right triangle, okay? What we want to also prove is OEM we want to prove this, right? Is also we want to prove this is also a right angle, okay? So now let's see. let me using this. Okay, so this one is the radius and the touching point, so this is the 90 degree, and this is the radius and that, so there is another 90 degree, there is another 90 degree, there is another 90 degrees. Okay, so this O1 and O2. So we know the O1 PM, let's highlight this, O1 PMT. Okay, these are concyclic because 90 plus 90 is 180, so those are concyclic, right? So we have this one is alpha and this one is alpha, and the same reason we can see the O2 QMT is also concyclic, right? So now we know this one is beta and this one is beta. Okay, so based on here, we know this angle is 90, right? So alpha plus 90 plus beta is 180. So alpha plus beta is 90 degrees, right? So that's why alpha and the beta is 90 degrees. Also, we can have this one is 90. Then we can get O1 M O2 is equal to 90. The four balls with radius 1 are tangent to each other. Okay, four balls are tangent to each other. It will be like this. It's the center. Okay, it's center with the radius of 1. So the four balls, the center of the four balls is A, B, C, D, and the center can construct a regular tetrahedron. Okay. What is the radius of the smallest sphere that can enclose them, right? So the smallest sphere is just touching all the points. So like we touching this point, right? There is a ball here. There is a ball here, right? We want to find. Okay, so where do we find the center point, right? So we can make it touching, right? So we can see. Okay, the center point we want to find is we want to find a point has equal distance to all of the point and then extending another one, right, to touch every ball. So now the question is we need to find equal distance to every point, right? So the center must be here. Okay, so here is the O, here is this, so we must be something like this. So we have the D of the O, right, and here is the C, and this, so we must have the X and the X. Okay, now let's see, this is the 2, and this is the root 3, and the 2/3 of the root 3, right? 2/3 of root 3 is 2 over root 3. And this side is the 2, the OD equals 2 times the 2 over 3. Then this is the 2 square root 2 over 3 minus X. Okay. So now we have a Pythagorean theorem. We can apply Pythagorean on this one, right? So this Pythagorean tells us the 2 root 3 minus X squared plus the 4 over 3 equals X squared. So by solving this equation, we know x equal root 6 over 2, right? So if we know the x, that's this, then we add another one. So this is the radius. Okay. Now the last one. Okay, the last one of this challenge problem. So diagonals AC and BD of regular heptagon, okay, 7 sides. A, B, C, D, E, F, G, okay. So there is a circumcircle, okay. If yeah, I don't need to draw this, but it's draw for you to be able to see the center angle and the inscribed angle, okay. Okay, so there is a circle. You can see each side, okay, each side has an angle of the 2 theta, right? Each arc. So AB arc equal to BC arc equal to GA arc equals 2 theta, right? So, and the inscribed angle is half of the arc, right? So let's see if we can connect the AC and connect the BD and connect the AD. Okay, so here is the X. So it want to ask you to prove the AB plus the AX equals AD. Okay, so now we can see the 14 arc together is 360, right? So 7 theta is 180. Okay, now let's see some angles. So AB, the arc, the inscribed angle here is theta, right? CD is also theta, and also this angle is theta. The ABD, right, is 1, 2, 3, 4. That's 4 theta. Because the AD arc, right, you can count in how many theta. 1, 2, 3, 4. That's 4. And also this one is 4 theta. And this one is theta because it's a BC arc, and this is theta. Okay, so we can use the law of sine on the triangle, right? So let's see. Let's apply law of sine on triangle ABX. Okay, so let's assume the side length is 1. Okay, make it simple. So here its angle is 2 theta, right? Because it's the this is the exterior angle of the ADX. Okay, ADX. So the ADX, this is the exterior angle. So it's theta plus theta is 2 theta, right? So let's apply law of sine on ABX. So we want to see the AX over sine the 4 theta is equal to 1 over the sine of the 2 theta. So we have the AX equal to the sine of the 4 theta over sine of the 2 theta. Okay, now we solve the AX. Now let's solve the AD. Law of sine put on triangle ADB. Then we have the AD over the sine of the 4 theta is 1 over sine of the theta. So we can solve this is AD is equal to sine 4 theta, and sine theta. So we can see one thing, okay? So 7 theta is 180, right? So we can get the 4 theta is 180 minus 3 theta. Then what we can get is sine of the 4 theta is sine 180 minus 3 theta is sine 3 theta. So 4 theta is 3 theta. So it's sine 3 theta over sine theta. Then we can use the triple trigonometry, right? It's 3 sine theta minus 4 sine cube theta over the sine theta. So it's equal to the 3 minus 4 sine square theta. Okay. So now we know the AD equals this, right? Now let's try to solve, okay? AD is equal to 3 minus 4 sine square theta. Okay, now let's track the other side. Okay, it's 1 plus AX is equal to 1 plus the sine 4 theta over sine 2 theta is equal to 1 plus 2 cosine 2 theta is 1 plus 2 and 1 minus 2 sine square theta is equal to 3 minus 4 sine square theta. Okay, so that's why you can see this and this are equal. So that's why AD is equal to 1 plus AX is equal to AB plus the AX. Okay, there are many problems you can use the trigonometry to do, because trigonometry using the law of sine and the law of cosine, it just implied all the relationships of the triangles in sides and angles. So yeah, that's it for this video. Thank you.